question 4, we have some sprinkler system, and the claim is that the average time among all the sprinklers to activate is no more than 15 seconds. So let me say that again. And we want to test if that claim, based on our sample of 6 systems, if that's actually true. So we have a sample of 6 times that it takes some sprinklers to turn on, and we want to see, by constructing a 90% confidence interval, if in fact this based on the sample, an average time of a population average of 15 is possible. So what we'll do is we'll make a 90% confidence interval based on the sample mean, the average of these 6 numbers. And if 15 seconds is in the confidence interval, then the system is probably working as specified. So that's our game plan. We're going to make this 90% confidence interval based on this sample and see if 15 is in this confidence interval. All right. So let's first calculate our sample mean. So our sample is 17 seconds plus 31 seconds plus 12 plus 17 plus 13 plus 25. I want to take the average of these 6 numbers, so I'll divide by 6. And if you plug that into your calculator, you should get 19.17 seconds. So that's our sample mean. Next thing we want to do is calculate our sample standard deviation. Remember that to find the sample standard deviation, a sample variance, S squared, we have a handy formula. That's the sum of the x values squared minus the sum of the x values over n, square this whole thing, and divide by n minus 1 since we're working with a sample. So let me make myself a table real quick. So that when I'm talking about x, I'm talking about these 6 values that were given: 17, 31, 12, 17, 13, 25. So if I sum in this column, that gives me the sum of all the x's. So if I add all these 6 numbers together, I should get 115. Now I'll calculate x squared because I need to calculate the sum of the x squareds. So 17 squared is 289, 31 squared, 31 squared should be 961, 12 squared 144, 289, 169, 625. So if I sum the x squareds, I should get 2,477. So now I can plug into my formula here to find the sample variance. So if I add up the x squareds, that's the 2477 minus the sum of the x's, which is 115, square that, divide by my sample size, which was 6, and then I divide by my sample size minus 1, which is 5. So let's plug this whole guy into our calculator. We should get, 54.57. So then my sample standard deviation, which is just S, as I take the square root of the variance, so the square root of 54.457, and I should get approximately 7.39. And that is my sample standard deviation. All right, so next, I'll put step 2 here. We want to find the t statistic corresponding to our confidence level and our degrees of freedom. So this part 2 is just like the question 3 that we did above. So, all right, so our confidence level is 90%. So that means that our area in both the tails, which is 1 minus the confidence level, which is 1 minus 90%, which is 10%. So the area in both tails is 10%. So the area in each tail is half of that, which is 5%. Notice that I'm talking about tails. I'm talking about the t distribution, and I'm talking about the area to the right and to the left of t and negative t. So this area right here is 0.05. Next thing I need is my degrees of freedom in order to find this t statistic in my t-table. This is my sample size minus 1. 6 minus 1 is 5. So my degrees of freedom is 5, and the area to the right of my t statistic is 0.05. So let's look that up in our t-table. So I want area to the right of 0.05 and a t statistic, a degrees of freedom of 5. So then, look in this column, and I should get the t statistic is 2.015. All right. So then the last part is we can make our confidence interval. Let's give ourselves some more space here. There we go. All right, so let's make our confidence interval. So we have one thing we need to do before we can jump straight in. We need to check our assumptions are true. We need to check a few conditions to make sure that, we're allowed to make a confidence interval. So we need to check that we have a random sample. Well, it tells us, it doesn't actually tell us that we had a random sample, so we will assume yes, because we're not told otherwise. Independence. I want to make sure that the functioning of one sprinkler is not affected by another. And we'll assume, yes, that the sprinklers work independently, because we're not told otherwise. We need to check that our sample size is less than 10% of the population. Well, our sample size is super small. So this is definitely going to hold. Do we have normality of the population? Well, we don't know. It's not told to us, so must assume that the population is normal. So we assume that all our conditions are met because we're not told otherwise. So then we can now construct our confidence interval. So our confidence intervals, we take our sample mean and we add and subtract our margin of error. Our margin of error is equal to our t-statistic times our sample standard deviation. Our t-statistic, remember we said, was 2.015. And we calculated our sample standard deviation was 7.39. So our margin of error, oops, actually, not quite. Our sample standard deviation, remember we need to divide by the square root of n. There we go. So I take 7.39 and divide by the square root of sample size. So then my margin of error should be approximately 6.079. So now I can find my confidence interval. My sample mean we calculated, that was 19.17 seconds. So I take 19.17 plus or minus my margin of error, and that gives me the interval of approximately 13.09 to 25.25. So now let's go back to our original question. We wanted to figure out if, based on our sample, is this time limit of 15 seconds, is that the case here? Are all the sprinklers based on our sample, do we estimate that the population mean is 15? Well, we look, is 15 seconds in our confidence interval? Remember that this confidence interval, the way we interpret it is, we are 90% confident that the population mean, the population average, is between 13.09 seconds and 25.25 seconds. 15 seconds is in this interval. So we have no evidence to conclude that the system isn't working as specified. So let me say this. So we have no evidence to conclude that system is not working as designed. If 15 were not in this interval, then we would say that our system isn't working as it should.